Okay. So, hey guys, welcome to the solution video or the PCD of Codeforces Round 932 Div 2, right? Today we'll be discussing problems ABCD. So let's start with problem A. Entertainment in MAC. What does the problem say? You are given and you are given a string and an even integer n. There are two types of operations that you can apply to it. Okay. Add the reverse string s to the end of the string s. Okay. So if it is CPM, then it becomes CPM MPC. Otherwise, reverse the current string s. You have to perform exactly n operations. Note that you can apply operations on different types in any order, but you must apply n operations in total. So what does the problem statement say, guys? I solved it generally for n, not n is even. So let's discuss. Let's say we are given a string s, which is CPM, okay? And we are told that we have to do n operations. Now, what can we do in these n operations? We can do two type of operations. What kind of operations can we do? In first operation, what do we do? S is equal to S plus S reverse. Okay. Basically, what does the string S become? It becomes S plus reversed S. So for example, CPM, if I wanted to do one operation right now, it would be CPM MPC. Okay. Now, otherwise, what is the second choice I have? I can just S is equal to S reverse. These are the two choices that I can make. Now, guys, let's discuss some observations in this problem and let's see how to solve this. So first of all, let's discuss that what happens when we reverse something, right? So we have CPM, we reverse it, and then we get MPC. And another thing to notice is that, let's say n is odd, okay? N is 1 or 2 or 3, so on and so forth. Or consider, let's say n is even right now. So let's just do that. So n can be 2, 4, 6, 8, 10, so on and so forth. If we do two reverse operations on CPM, what does it become? If I do one reverse operation on CPM, it becomes MPC. If I do one more reverse operation on MPC, it becomes CPM. So for n is equal to 2, if I only do the reverse operations, then I again get CPM. Now similarly, when n is equal to 4, when n is equal to 2, I had CPM. So I can, if I do only reverse operations, I get CPM again. So what is the general idea right here? The general idea is that if I only do reverse operations, my string does not change. Is this much clear, guys? Tell me. Put a yes in the chat if this much is clear. If I only do reverse operations, my string does not change. Is this observation clear? Yes. Okay. Now, if this observation is clear, let's move at another observation. Okay. This observation is clear, first of all, that if I had to do only two reverse moves, 4 reverse moves, 6 reverse moves, or any kind of even number of reverse moves, my string remains constant. Okay. Now, what is the second observation? Let's say CPM, I have one string, and second string is CPM MPC. In both these strings, this one is the smaller one. Basically, if I have a string, adding too many reverse operations is not optimal. What I'm basically trying to say is, we want to do as less reverse operations as possible. Reverse operations as possible. Is this much clear, guys? Tell me. Is this much clear? Put a yes in the chat if this is clear. Okay. So what did we discuss? First of all, we discussed that if we do only reverse operations, then my string does not change. Apart from that, second thing that we discussed is, if I have a string CPM, okay, and then if I append something to it, the reverse of it to it, the original string is always going to be smaller, lexicographically smaller. Okay. Now, if these two observations are clear, let's move on to the final observation that will help us solve the problem. The last observation and basically the solution to this problem is that, let's say I have MPC, okay. This is the string that I have. And in the problem statement, it is given that n is even. It is given that n is even. Okay. Now, if I only do reverse operations, I'm going to be left with MPC itself. So one potential answer that I have is MPC. Okay. This is one potential answer. Now, whenever I have MPC, will I append CPM to it? I won't, right? Because MPC is the smallest possible string, and MPC CPM is greater than MPC. So I would never really do a plus CPM on this MPC string. Is this much clear, guys? Put a yes in the chat if till now what I have said is clear to you. Okay. Now, if this much is clear, let's see what happens when we do one reverse operation. Okay. On the first operation, if I do a reverse operation on MPC, it becomes CPM. Okay. Now, if you notice, CPM is smaller than MPC. Now, how will this help us? If CPM is smaller than MPC, if I add infinitely any number of characters to the right of it, CPM is still going to be the smaller string. Do you notice this, guys? Like, CPM is already smaller than MPC. Okay. Now it does not matter what characters I add in the end of it. If I can still get CPM, CPM is going to be smaller than the string MPC. Is this much clear, guys? Tell me. Now, okay. Now, if this much is clear, what is our strategy here? If I want to make this CPM persist, okay, basically, I want CPM to be my answer, right? But if I reverse one more time, it's going to be MPC. So how can I stop this? I will do the first kind of operation, this kind of operation on it, and let's see what happens. So this becomes CPM MPC. Okay. This right here is still smaller than MPC. We agree upon that, right? CPM MPC is smaller than MPC. And now, if I do a reverse operation any number of times, we get the same string as we discussed. I did one operation, I did two operation. I spent even number of operations getting CPM MPC. Now, no matter how many operations I do, basically 3, 4, here I'm going to get CPM MPC again. Here also, I'm going to get CPM MPC again. And since CPM MPC is smaller than MPC, that is my answer. Do you guys get the solution? Put a yes in the chat if this much is clear. Tell me, guys. Yes. So what is the solution? Let's say we have two strings S and sref. If S is smaller than equal to sref, my answer is going to be S. Basically, if I have CPM as my string, or let's say AA as my string, if I reverse this will become MPC. MPC is greater than CPM, so we don't really require the reverse of it in our answer. So in that case, my answer remains as S. But if this is not the case, if S is greater than sref, then what is our answer? Our answer is sref plus S. This is just an if-else statement, and the time complexity of this is O of n, because we'll need the reverse of a particular string. Is this much clear, guys? Put a yes in the chat if this much is clear. If it is not clear, if you are not able to solve today's A, tell me that as well. Or if what I explained is not clear, do let me know. Okay. Somideep says clear. Noob says only able to solve it. No problem. We'll be discussing A, B, C, D, right? So if this much is clear for problem A, let's look at the solution. I actually didn't read even integer n in the problem statement, so I solved it for any n. But let's have a look. The idea is very simple. Like, let's just ignore this, right? This is not required. But we are going to need two strings, S and T, right? Now, if S is equal to T, then I'm going to print S itself. Or S is smaller than equal to T. Okay. If S is smaller than equal to T, I know that N is even. Just ignore all of these, guys. If S is smaller than equal to T, I'm just going to print S. Otherwise, if T is smaller than S, then I'm going to print T plus S. I assumed that N can be odd as well, so I solved it for the other case. But since it is never odd, it is never an issue. Is the implementation clear, guys? Tell me. It's okay if you took time for this problem. Now let's move on to problem B. If problem A is clear, what does the problem say? The problem says that there is an array of length n, and you want to divide it into k segments, right? And k is greater than 1, basically 2 segments or 3 segments, continuous segments, such that the max of the segment, max of all segments is the same. So let's try to understand this problem one by one. We are given an array. Okay, let's consider let's consider the third one. I think the third one is okay. So 0, 1, 7, 1, 0, 1, 0, 3. Okay. So we are given a particular array of size n, And what are we asked? Split the array into greater than equal to 2 continuous segments such that the max of all segments is same. Okay. Now, before moving on how to solve this, let's discuss what max is. Okay. Max stands for the smallest non-negative number that is not present. Okay. So basically, if max represents the smallest non-negative number that is not present, if I give you, let's say, numbers 1, 2, 3, 4, in this case, the max will be 0 because 0 is the smallest non-negative number that is not present. Similarly, if I give you something like 0, 1, 3, right? In this case, the max is 2. Okay. And in something like 0, 1, 2, 3, the max in this case is 4 because 4 is the smallest non-negative number which is not present. Okay. Now, if we know what max is, in this particular test case, if we split our array like this, okay, this is a valid answer because the max of this range is 2. The max of this range is 2. Okay. Now, how do we solve this problem is the question, right? So here 0, 1, 7, 1, 0, 1, 0, 3. Okay. Now, what do I want you all to assume is that let there be any optimal answer. Okay. Assume that there is any optimal answer. Basically, let's say the max of there exists some answer. Okay. And in this answer, the max is, let's say, x, or in our case, let's say 2. So let's find all the subarrays, continuous subarrays where the max is 2. So as you can see, this is one subarray, this is the other continuous subarray, and this is the third continuous subarray. Do you guys follow till here? Is this much clear? Like, let's assume the answer had max x. Okay. We don't know it yet, but there is some x such that the answer is present. And there are some subarrays, okay, such that this max of each subarray is x. Is this much clear? Let me write it down for you. Okay, we'll try to break down what I said. Let's assume the answer exists. Answer exists, okay. And the max for each subarray or each block, okay, is x. Now, what does this mean? This means that I have an array. I can break it into some subarrays greater than equal to 2 subarrays such that the max of each subarray is x. Is this much clear? Put a yes in the chat if this much is clear. I want to teach you all how to think mathematically. This is the mathematical statement, and this is what I'm trying to make you all think. Okay. Now, the thing to notice here is that, let's say there are two arrays, okay, A1 and A2, where both have max x, okay, both have max equal to x. Let's take a very common example. Let's say 0, 1, 3 and 0, 1, 4, 5, 8, 9, infinity. Okay. Infinity is of course not there, but let's say these are the two arrays that we have. Okay. The max here is 2. The max here is 2. The main observation here, guys, okay, the main observation that you require to solve this problem is that what will happen if I merge these two arrays? Merge these two arrays. Okay. If I merge these two arrays, the array becomes 0, 1, 3, 0, 1, 4, 5, 8, 9, and infinity. The max of this array is still x or still 2. 0 is present, 1 is present, 2 is not present. So if there are two subarrays with the same max, if you combine them, they still have the same max. Does it make sense to you guys? Now I will try to give you some intuition why this works. Okay. In both arrays, all numbers from 0 to 1 are there. Basically, if x is the max, all numbers from 0 to x minus 1 are there in both the arrays. But the number x is not there in both the arrays. So when you merge them in the final array also, there will be numbers from 0 to x minus 1 and the number x, which is our max, won't be there. Hence, when you saw that there were two arrays with max 2, when you merge them, their max remains 2. Put a yes in the chat if this much is clear. Especially the ones who weren't able to solve this, okay? I want the people who weren't able to solve this understand this problem. Now, we came to know that when we merge, max is same. Basically, if two arrays are there, and you merge them, the max is same. Now, if I go a little bit ahead, behind, and I take you all here, what did I say? Let's assume the answer exists and the max for each block is x. Basically, the answer exists and there are subarrays with max equal to x, right? So no matter how many subarrays are there, can I say that I can come, let's say there are m subarrays. I will just combine the first m minus subarrays into one subarray and I will keep the last one as it is. What is the max of the first one? It is still x. What is the max of the last one? It is still x. Is this much clear, guys? Tell me. Is this much clear that the answer exists? And let's say there are some subarrays that such that the max of each subarray is x. It's the same as saying that there are two subarrays, both with max x, because I will just merge all of the first whatever subarrays and I will keep the last subarray with max x. Since the answer, so before starting, since these subarrays had max x and I merge them, the subarray still has max x. Is this much clear, guys? Put a yes in the chat if this much is clear. Somadeep says it is clear. What about others? Anand says it is clear. Great. Okay. Now, what has our problem boiled down to? Our problem has boiled down to split array into two parts such that max is same. Okay. This is what our problem has trickled down into. This is all that we need to find. We discussed how this came right now, and this is what our problem has decomposed into. Split the array into two parts such that the max of both the parts is the same. Right? We just discussed that, right? Right here. Now, the thing is, how do you do this? A brute force approach could be, let's say this is my array. For every split, okay, for every split possible, let's say this is the split that I took. You find the max here and you find the max here. And if the max here is equal to the max here, you can say that you can split this array into two parts such that max from index 1 to, let's say, index I and index I plus 1 to n is the split. Is this much clear, guys? We can just iterate over where we are going to make the split. Okay. Let me just like this. Okay. These are the array elements. And then we can just check on the left and the right what is the max, and if max of both the subarrays that we made are equal, then we can say that yes, it is an answer, and we'll print I, 1 and I plus 1 and n. Is this much clear? Yes. Now, if this much is clear, how to do this efficiently? Okay, how to do this efficiently? Like, we can do this in O of n square or whatever, right? But this won't pass because n is smaller than equal to 1e5. So how to do this efficiently? So the idea is very simple. Okay. Let's say what was my array? It was 0, 1, 7, 1, 0, 1, 0, 3. So here I'm going to maintain two arrays. Okay. Let me just write it down. Okay. This is my prefix max and this is my suffix max. Okay. These are the two arrays that I'm going to maintain. What does prefix max store? It stores what is the max from an index to start, right? So for this, the max here is 1, the max here is 2, the max here is 2, and it remains 2. Okay. Right here, the max is 0, the max is 1, the max is 2, and it remains 2. Okay. Prefix max stores, let's say at index I, what is the max from index 0 to index I, and suffix max stores suffix, let's say from index I to index n minus 1, what is the max. And how do we check if there is a split? We just check an index I. If prefix max of I is equal to suffix max of I plus 1, what does this mean? This subarray's max is equal to this subarray's max. Okay. Then we can say that the split exists from 1 to I or 0 to I and I plus 1 to n minus 1. Is this much clear, guys? How to compute this? I will show you. But is this clear? Tell me. Tell me guys, is this much clear? Somodeep says yes, Keshav says yes. Great. So if this much is clear, let's see how to implement this, right? So the implementation here is very simple. We are going to require three arrays. One is the array that we are going to take in. The second one is our prefix max, and third one is our suffix max. In the answer, you can see that I iterate from 0 to n minus 2. And if prefix I, basically prefix max I is equal to suffix max of I plus 1, it means that you can split this array into two subarrays such that the max is same. So I just have an answer vector. You don't really need it. I could have written it here as well, but just because in the contest I wanted to do it fast. 1 to I plus 1. I'm doing it in one based indexing. Okay. So from 1 to I plus 1 is my one range, and from I plus 2 to n is my other range, and I just break. Now if answer vector is empty, then I print -1. Otherwise, I print 2 and I print whatever the elements are. Now the thing is how to compute max. Okay. This is what is important. Let's say I wanted to compute max. Okay, I'll just show you all here. Once 0, 1, 7, so on and so forth. Okay, I am iterating in this way, and since I'm storing prefix of prefix maxes, okay, elements keep getting added. Okay, elements don't reduce, and there is a property of max. Let's say the array is 0 and 1. Okay, let's say you added 3 in it, and after that you added 2 in it. So the array was 0, 1, then it became 0, 1, 3, and then it became 0, 1, 2, 3. The max here is 2, the max here is 2, the max here is 4. The property is that the max never decreases. If you only keep adding elements to a particular set, the max will never decrease. This is a very important property. Do you guys agree with this? If I only keep adding elements to my array, the max of the array cannot decrease. It will only increase because I'm not removing any element. I'm just adding elements. Does it make sense, guys? Put a yes in the chat if it makes sense. Okay. So here, what am I doing? I have two sets. Okay, prefix max and suffix max. I'm inserting ARRI into my prefix max. And let's say my current max is A, right? My current max is A. So till prefix max dot count A, basically in the set that element is available, I just do A plus plus. What do I mean by this? Here, my max was 2. I inserted a 2 here, right? So is 2 present in this set? Yes. So I'm going to do 2 plus plus. My max became 3. Is 3 present in this set? Yes. So 3 plus plus. My max became 4. Is 4 present in this set? No. So I break. So the max of this array is 4. This is what I'm doing with this piece of code. I insert the element into my set. Then while my current max is present in the set, I just do max plus plus, and then prefix of I, basically prefix max of I stores the max for that particular index. Is the implementation clear, guys? Put a yes in the chat if implementation is clear. There are multiple ways to implement this. I just implemented it in the most familiar way that I could, right? So this is more or less it. It was a constructive kind of problem. We saw how you only need to take care for two parts. Now let's look at a very interesting problem. Like, the main thing to notice in this problem was something very interesting. Let's have a look. Okay. What does this problem say? This problem says that you are given this function. Okay, let me just write down this function. Give me 1 minute. Okay. K I is equal to 1 API plus summation 1 K minus 1 P of Pi minus P of Pi plus 1. Okay. Okay, guys. So what does the problem statement say? The problem statement says that we are given an array of length n. Okay. Basically, where there are two values, there is AI and BI, and there are n such elements. AI plus 1, so on and so forth, A2, B2, so on and so forth, up to AN, BN. This is the array that we are given, or let's say set of elements, right? Now, we are also given an integer L. What does integer L say? It says that whatever this function is, its value should be smaller than equal to this limit. Okay. Let's say we have elements 1, 2, 2, 3, 4, 5, 6, 7. Okay. And let's say limit is 100. Okay. This is what this is. So what does the problem ask? What is the maximum number of indices that you can choose such that this sum right here is smaller than equal to L. Right? Currently, the answer for this is 4, because if you take all of them, the sum is not going to cross 100. But this is what the problem asks. Is the problem statement clear to you guys? Tell me, guys, is the problem statement clear? If no, tell me. Like, if problem statement is only not clear, tell me. Otherwise, if it is clear, put a yes in the chat. Anand says it is clear. What about others? Okay. Tushar says clear. Ekam says clear. Great. Now, what does the problem statement exactly say? The problem statement says that we have to choose some indices. Okay, P2, P3, whatever, and up to Pk. Okay. It is not necessary that this is sorted. Basically, if my elements are on the 0th index, I have 1, 2. On the first index, I have 3, 4. On the second index, I have 4, 5, so on and so forth. Then this Pi, you can choose the indices as 0, 1, 2. Okay. You can choose the indices as 1, 2, 0. Okay. And you can choose the indices as anything, right? You can choose it as 2, 1, 0 as well. And it is not necessary that all of this will have the same answer. Basically, what I'm trying to say is all of these can have different answers. This is the first thing that you need to observe. Like, if I choose which elements I want, okay, let's say I wanted the first element and the third one, and also the first one. Okay, let's say I wanted three things. Now, depending upon how I order their indices, the answer will change. Let's take an example and see how. Basically, let's say the three elements I want is 1, 3. This is one pair. The second one is 2, 4, and the third one is 3, 5. Okay. What are we? And this is index 1, this is 2, this is 3. What are we asked to calculate? We are asked to calculate summation API, okay, plus summation of B of PI absolute. Okay, B of PI minus B of PI plus 1. Okay, this is what we are asked to calculate. Now, if I choose my order of indexes as first 1, 2, 3, then 1, 3, 2, let's take these two only, right? So summation of API, basically these values, is going to stay constant only. Like no matter what elements I take, this part of the equation is constant. Okay, this is just going to be 1 plus 2 plus 3 anyhow. So 1 plus 2 plus 3 is 6. So this is going to be 6, and this is also going to be 6. Let's calculate this. When I take 1, 2, 3, 4 minus 3 is 1, right? After that, 5 minus 4 is 1. Now, when I take 1, 3, 2, 5 minus 3 is 2, right? And 5 minus 4, right? 5 minus 4 is 1. So in this case, my answer was 8, and in this case, my answer was 9. So do you guys observe that the order which I take really matters? Do you guys agree upon this? Put a yes in the chat, guys, if you guys agree upon this. Tell me, guys. Anand says yes. What about others? What about Vaibhav? Right? Do you guys agree that when I change the order, the answer might change? Okay. So the question is, let's say I give you a pair of indices. Okay. The same thing. I'll just erase all of this. Okay. You just erase all of this. We came to know that this is same for all orderings. This is same. Okay. Or remains constant. This is what changes. The question here is, okay, I told you that the indices you pick are these are the elements that you have to pick. What is the minimum value you can get? Basically, what is the best strategy to order these elements such that the value you get out of this function is minimum? What do you think, guys? What is the solution to this problem? Okay, Ekam says a very good point. Vaibhav also says a very good point. What do you say? You sort by B, right? So why does this work? Let's have a look. Okay. When we keep this sorted in values of B, you can see that 1 plus 2 plus 3 remains constant. Then it is 4 minus 3. I'm just removing the absolute. Okay. 3 minus 4 absolute is 4 minus 3. Then it is 5 minus 4. If you actually go on to expand, this is 1 plus 2 plus 3 plus 4 minus 3. plus 5 minus 4. This is constant. Let's forget this for a bit. Can you see that this plus 4 and minus 4 gets cancelled? And what is left? It is 5 minus 3. What is 5 minus 3? 5 is my largest B and 3 is my smallest P. Let's say the B values were 1, 2, 3, 4 as well. It would have been 2 minus 1 plus 3 minus 2 plus 4 minus 3. If you can see, this plus 3 minus 3 cancels out, this plus 2 minus 2 cancels out, and what is left? 4 minus 1. Now, if you, this is a task for you, okay? If you want to know why this is the most optimal, take any other ordering. Take any other ordering. The min answer you can get is 4 min max B value minus min B value. If you take any other ordering, you add an extra something delta. Okay, let's call it delta. For example, instead of 1 2 3 4, we took 1 3 2 4. Okay, here it is 3 minus 1 plus 3 minus 2. You can already see that in this case, this plus 3 and minus 3 cancelled. In this case, we already have plus 3 and plus 3. And after that, it is 4 minus 2. So this is 2 plus 1 plus 2. This is 5. But here our answer for 1, 2, 3, 4 is just 3. So do you guys observe that when we sort by the values of B, when we sort by the values of B, then this summation absolute BP minus BPI plus BPI plus 1 is minimum. Is this much clear, guys? Tell me. Weber says he has a question. Sure, type it in the chat, Weber. Sure, you can unmute.
Yeah, Gaurish, I was just like looking at this question and I figured out that there was like some kind of argument involved in that, right?
Yes.
Right, I was not able to prove it like during the contest because I tried figuring out by binary searching an answer, but like it didn't work.
Okay.
So the main point was that like when you were sorting these based upon the value of BI, like where the very first element was the smallest in that, and
Yeah.
along with your AI will also be get sorted like if you are taking like a vector of pair.
Yeah. Yeah.
So like how eventually are you coming up with that solution that the A part will be optimally taken because like for every
Yeah. Yeah.
element
Yeah. We have not gotten to that part. It is,
okay,
we have not gotten to the solution yet. I'm just talking that if I have given you a set of indices, if you sort by the values of B, like if I tell you that you have to take index 1, 2, 4, 5, okay. In this case, like I already know what elements I'm going to choose. In that case, if I tell you to find the minimum value, then you will sort these indices based on the value of B, and that is when summation API plus this thing will be minimum. That is what I discussed right now, not about the original problem itself. I'm getting to that right now. Is this much clear? Like if I tell you that you have to take these indices, then what is the minimum
yes,
answer?
yes, I was able to come up with that like the observation
Yes.
you were talking about.
Okay. So we discussed that if we know what indices to pick up, to pick up. Okay. Then what is the value? The value is nothing but summation A of Pi plus max B. Okay. Whatever is max in the value of B minus min in value of B. Like if you put the values, for example, 1, 2, 3, 4, you notice that everything gets reduced apart from this plus 4 and this minus 1. 1 is the min element, 4 is the max element in B. So what is the value of this summation BPI minus BPI plus 1? It is just max B minus min B. This is what the value of our function is going to be. Put a yes in the chat if this much is clear. Okay. Right. Now, what are we asked? We are asked that we need to maximize the numbers that we take. The numbers that we take. Okay. Now you might think that, okay, I know this much, right? I came to know about this observation that summation API remains constant, like we can't really change that. But depending upon the order, it is just max B minus min B. This will give us the minimum value possible. So how do we convert this into solving our problem? How does this help us? Okay, let's take an example and I'll show you how to solve this. The first step that we do is the basic idea that we want to do here is fixing max B and min B. Okay. This is what our basic idea is. What do I mean by that? Let's see. Okay. Let's say I'm taking it in sorted order. Let's say it's 4, 1, 10, 2, 3 and 3. Let's say 4 and 5, and these are my elements. Okay. Just, and let's say 13 and 6. What did I tell you? Just bear for me for a minute. We'll fix what our max B is and we'll fix what our min B is. Okay. Let's say I fixed my min B as 2. And let's say I fixed my max B as 5. Basically, I fixed my min B over here and I fixed my max B over here. Do you guys agree? Like, I am not telling what elements we are going to take, but whatever elements we are going to take will be in this range only. Since I know what can be the min value of my B and max value of my B, like let's say if I fix something, like I assume that it can be anything, right? For now, I'm telling 2 will be my min B and 5 will be my max B. Then the elements that I can pick up is in this range only. Is this clear, guys? Like if I fix where my min B is going to be, if I fix where my max B is going to be, the elements that I pick up are going to be in this range. I cannot take 4, 1 because my min B has to be 2 and here min B is 1. B is 1, which is not in that range, right? Put a yes in the chat if this much is clear. Like if I fix where my min B is, if I fix where my max B is, the elements that I can take is in this range. Okay. Now, these are the elements that I can take. Okay. And I have fixed my min B and max B. If I have fixed my min B and max B, I am forced to take these two elements. Okay. Just assume that I am forced to take these two elements. So my answer is already going to be 10 plus 4 plus whatever I take plus 5 minus 2. Okay. As we discussed, the formula is summation of API plus max B minus min B. Since I fixed what my max B and min B is, the first two values I have already taken, whatever min B and max B had. Apart from that, the summation BPI part is always going to give 3, right? Now, we have some elements in the middle. Here there is only one, but let's say there were 10 elements in the middle, okay? You had to pick as many elements as possible such that their sum of AI, whatever you picked AI, you picked A, J, K, whatever. You have to pick as many elements as possible such that this sum is smaller than equal to L. What do you do? Tell me, guys, what do you do? Any idea? What did we do? We fixed a min B, we fixed a max B. Okay, I know what the values are. This is AI. Let's say this is A min B plus A max B. Then we are going to take some elements, okay, that are in the middle of these two elements, okay, right? And after that, this is just B max minus B min. This is what the value is. Now in this, I want to add as many elements as possible such that this value is smaller than equal to L. Don't you guys agree that if I greedily take the smallest AI values in this range, it will always result in this particular constraint, like this constraint that I said that it has to have min be this and max be this. It will result in the set with the largest size. Basically, what I'm saying is, I know what my min b is, I know what my max b is. I have to pick some elements from the middle such that their sum is smaller than equal to L. So can't I just sort these elements in the middle by the values of AI, and I will pick as many elements as I can because till my sum that it gives is smaller than equal to L. Tell me, guys. Exactly. Smallest until I can accommodate something and then remove the largest. This is a very simple greedy strategy and I hope you understand. Okay. So what did we do till now? Let's just recap. Okay. What did we do? We sorted according to B values. Okay. Now I have these elements. For every pair of elements, right? For example, this is 1 comma 1, this is 2 comma 2, this is 3 comma 3. Or let's say I'll do this ulta. Okay. 9, 8, 7 comma 4, 6 comma 5, 5 comma 6 and 4 comma 7. Okay. For every pair, we fix what the min I, since it is sorted in B values, I fix what the min B is going to be. I fix what the max B is going to be. Okay. Now, I know what this value is and this value is. So the value of my function is 9 plus 4 plus whatever I take plus 7 minus 2. Now, whatever my limit is, I want to fit as many elements in this. And what am I adding here? I'm only adding AI values, AI, AJ, whatever, whatever. So in these elements, these are the A values. Okay. wouldn't I give my first priority to adding 5? Then if the limit is still smaller than equal to L value, then I will add this 6. Then I will add this 7 and then I will add this 8. Basically in sorted values of A, I will keep inserting. Is this idea clear? If this idea is clear, we'll just move on to the implementation. Okay. Now, if this idea is clear, how do we actually implement this? Because if you go about doing this as I said, right, you fix every pair, this is O of n square, okay, and then you do n log n, you sort this somehow. So as someone pointed out, it's going to be O of n cube log n, but n is smaller than equal to 2000, right? So this is going to TLE for sure. So how do you actually do this? So the idea for doing this is you maintain two multisets or two priority queues. Okay. And how do you do this? Let's see. For example, you have sorted the values in order of B and you just calculated the set. Okay. What are the two sets? One is the elements that you have taken right now. Okay. For example, when you are calculating this, the elements that you took in this, right? What are we told? We have to choose some indices. So whatever elements you choose, they are in a set called taken, multiset called taken. And the elements that are not taken in a set are in a set called not taken. Okay. Now you know the sum of elements of taken, right? And you know what elements are not taken. You calculated it for this, and now you just move this pointer here and you want to calculate it. So what do? You just, this element is what you need to push in your not taken multiset. Okay. You push this element in your not taken multiset, and now you apply a greedy strategy. Let's say the values that you took in taken are, let's say 1, 2, 5. Okay. And the values in your multiset not taken are, let's say 4, 6, and 7. Or let's say even better, 2, 3, 6, and 7. Don't you guys agree that if I remove these two elements from my not taken multiset and I put this in my taken multiset, the sum does not really change, but the number of elements that I could take increase. Like I remove this 5 from here, I put this 5 inside this set, and then I take these two elements 2 and 3 and I put it in this multiset. So my taken becomes 1, 2, 2, and 3, and my not taken becomes 5, 6, and 7. Okay. So this is a greedy kind of strategy that we are going to use. I'm not going to get into a lot of depth on how to implement this. I'll show you the code. But this over all iterations won't be greater than O of n square, like summation, like for everything. For example, if you fixed a particular this and you iterated the second pointer from here to here to here to here, the idea is that this taken array, it will have only n removals, right? Basically, if the array is 1, 2, 3, 4, 5, or whatever, in whatever order it is, when you are at the end, the taken multiset will have the first how many ever sorted elements, right? And all others will be removed. And once these are put in, they will never be removed. So it will just be O of n per fixed min b. And since there are n min b's, The time complexity of this won't be O of n square over everything. I am not telling it is going to be O of n square into O of n square. I am telling you that over all the pairs that you do, it is going to take O of n square time. So the total time complexity is going to be O of n square log n, because insertion and deletion in multiset is log n, right? If you want to look at why this works and so on and so forth, in the editorial, proof, mathematical proof for this is given, right? You can just read at it and have a look. Is the solution clear, guys? Like what we are trying to do and how we are going to do it? Is that much clear? Vaibhav, Ekam, tell me. Put a yes in the chat if this is clear. Right. Now, if this much is clear, let's just have a look at the code. Like I've written pathetic code, just ignore it, right? So I'm taking in my array, I'm taking in B first and then A. Then I sort these values depending upon their B values, right? And then I'm fixing my min B. This is done by this particular array. And I'm fixing my max B. This is done by this particular for loop. Sorry. Now, I have two multisets, taken, not taken, and my current sum is 0. Now, what is fixed? Fixed is whatever the A values of my elements that I fixed was. And what we discussed, it's going to be B max minus B min. So that is what I have added here. Now, apart from that, I just write a greedy kind of while loop. Like first, when both of the elements, both of the multisets are not equal, if the largest element in the taken multiset is greater than the smallest element in the not taken multiset, I just swap them, right? Basically, if the taken multiset is 1, 2, 3, 5, and the not taken is 2, 3, 4. So I can just swap 2 and 5, right? Because 5, it is better to have a 2 rather than a 5. So that is what this while loop does, right? Now, after this, there are some conditions. Like this is not the best implementation. If you want to just look how to implement this optimally, you could maybe have a look at the editorial code that is much more cleaner. But here, first, I just check the largest element in taken and smallest element in not taken. If largest is greater than the smallest in not taken, I just swap them, right? I insert the smallest into taken and largest into not taken. And after this, while sum minus fixed is greater than L, basically my taken multiset is going to have some sum, okay? And there is a fixed cost. So while sum plus fixed is greater than the limit, I just keep removing the smallest elements, the largest elements, because removing the largest elements is going to reduce my sum by the most. Basically, what I'm trying to say is, let's say my taken multiset is 1, 2, 3, and 5, right? And my limit is 6 or 7. So what element would I remove such that this value reduces by the most? Let's say the values are 1 plus 2 plus 3 plus 5. I would want to remove the largest element, right? So that is what I do using this while loop. And using the last while loop, what I do is, if I can add as many elements, like if there are some elements in not taken, and adding it won't, adding it will be in the limit, I just keep adding it, right? I add it to my sum, then I insert it into my taken, I remove it from not taken. And then answer is 2 plus taken dot size. Why is it going to be 2 plus taken dot size? Because my multiset size plus I fixed two elements, right? I fixed the j index and I fixed the I index. So it's going to be 2 plus taken dot size. Is this much clear, guys? Put a yes in the chat. Vaibhav, Ekam, were you guys able to understand this? Great. So we did problems A, B, C, and C was actually a bit complicated this time. We had to analyze quite a few things. Now, having a look at problem D. D is actually quite easy. It's not that hard, right? Just give me one moment. Let me drink some water. Good proceed. Great. Okay. So what are we given in this problem? You are given a set S of size n and some strange integer c. For this set, you need to calculate the number of pairs of integers x comma y such that x smaller than equal to y smaller than equal to c. X plus y is not contained in the set S. Also, y minus x is not contained in the set S. Okay. We are also given an example. Let's take in the example 3, 3, 1, 2, 3. Okay. This is actually fairly simple. Okay. If you guys actually went on to solve D, D was very easy. So we are given an array of size n and we are given an integer c. What are we asked? How many pairs of integers x comma y is there such that first x smaller than equal to y, both x and y are between 0 and c, so 0 smaller than equal to x, smaller than equal to y, smaller than equal to c, right? And no element in this array, like let's say I chose let's say this x plus y, x comma y is 1 plus 2, right? Or whatever I choose as x comma y, x plus y cannot be in the array and y minus x cannot be in the array. Okay. These are the two constraints. Is the problem statement clear? For this particular problem, the answer is 3 if I'm not wrong, right? Yeah, it is 3. Now, this problem is actually very simple, but let's see how to solve this. What are we given? We are given an integer n, we are given an integer c, and we are given an array of size n, which is already sorted and it is made of distinct numbers. Okay, this actually gives out the solution somehow. Okay, like this is already sorted and it is made of distinct numbers. The problem that we are going to take is 3, 3, 1, 2, 3. 3. Okay, we're going to take 3, 3, 1, 2, 3. Okay. So first of all, I want you all to tell me how many pairs can we make? Like if you forget this constraint, okay, that this array exists, how many pairs x comma y can you make such that this is satisfied? Let's have a look. Let's fix y and see what we are doing. For example, here it is 3. So we'll take y is equal to 0, y is equal to 1, y is equal to 2, and y is equal to 3. So what pairs can we make? Here we can make 0, 0. Here we can make 0, 1 and we can make 1, 1. Here we can make 0, 2. Here we can make 1, 2. Here we can make 2, 2. Here we can make 0, 3. We can make 1, 3. We can make 2, 3. And we can make 4, 3. 3, 3. Sorry. So do you guys see how many pairs can we make? We can make 10 pairs here. Okay. And how much is 10? 10 is basically for 0, you can make 1 pair. For 1, you can make 2 pair. For 2, you can make 3. For 3, you can make 4, so on and so forth. This is nothing but sum of the first n plus 1 numbers. C is 3, we did 1 plus 2 plus 3 plus 4. If C was 4, then we have done 1 plus 2 plus 3 plus 4 plus 5. So the number of pairs you can make is just C plus 1 into C plus 2 divided by 2. Do you get this, guys? Like if you fix y is equal to 0, y is equal to 1, y is equal to 2, y is equal to 3, the total number of pairs that you can make is just C plus 1, C plus 2, so on and so forth. So in this particular case, since C was 3, the total number of pairs that I can make is just 10 pairs. Okay. What about others? Is this much clear? Like this is the number of pairs that you can make. Now, let's try to count how many pairs satisfy this constraint and how many pairs satisfy this constraint. What am I saying is that I know how many total number of pairs are there. Total pairs is equal to C plus 1 into C plus 2 divided by 2. Now what will I count? Let's say we count two things. Okay. Number of pairs such that x plus y is there in the array. Okay. Is there in array. Similarly, number of pairs such that y minus x is there in the array. So don't you guys agree that our final answer is going to be this total minus something? What is this something? I'm going to get to right now. But we just remove the pairs that are not valid and our answer is just total minus something. Is this much clear? Okay. Now, how do we count this? Isn't this basic set theory? Let the number of pairs that such that x plus y is there in the array be A. Okay. Let number of pairs such that y minus x is there in the array be B. So isn't this something? Isn't this just number of A plus number of B minus number of A intersection B? If we look at it as set theory, let's say this is the number of pairs such that x plus y is there in the array. This is the number of pairs such that y minus x is there in the array. This intersection is x plus y is also there, y minus x is also there. So this something is just this. We need to count this. And if we can count this, total minus this whatever value is our answer. Do you guys agree upon? Tell me, guys. Okay. Now, how do we count this is the question. If we are able to count this fast enough, we'll get AC. Otherwise, we'll get wrong answer. We won't be able to submit. So, first thing to notice is that how to count the number of x plus y pairs that are present. Okay. Let's take an example. Okay. This 1, 2, 3 only. So 3, 3, 1, 2, 3. How many pairs are there such that x plus y is 1? We won't be able to take them, right? This is 0, 1. This is the only one which is possible. For this, how many are possible? 0, 2, 1, 1. For this, how many are possible? 0, 3, 1, 2. Then there is, yeah, I think this is it. Yeah, I think, yeah, this is it. So basically, if you notice, if we take any element, okay, x, we can take 0, x, then we can take 1, we can take x minus 1, then we can take 2, we can take x minus 2, so on and so forth, till these elements are smaller than equal to. Like this value can never exceed this value. Is this much clear, guys? Tell me. Like if I wanted to count the number of pairs x plus y, for every element, since there are only unique elements, for every element I will count how many pairs are there such that x plus y results in that sum. And this is going to be disjoint, okay? Can someone tell me why are the pairs that equal to sum as 1 going to be disjoint from the pairs such that sum is equal to 2? Tell me. Can someone tell me? Like the pairs such that x plus y is equal to 1 are going to be disjoint from the pairs such that x plus y is equal to 2. Can someone tell me why? Very simple answer. Yeah, because 1 and 2 is different, right? X plus y is equal to 1, x plus y is equal to 2. X comma y cannot be same in both of these, because if it was same, then math would be broken. Like if some value sum is equal to 2, its sum of values cannot be 1. As simple as that. That is why for every distinct number, if you just take the sum of pairs, let's say you calculate the number of pairs that equal to sum is equal to 1, number of pairs such that sum is equal to 2, number of pairs such that sum is equal to 3, then the summation of all this is just going to give you this value. Is it clear? Now, for a particular x, let's say 1, okay, how many pairs we can make? We can make 0 comma 1. How many for 3? We can make 0 comma 3, 1 comma 2. How many for 4 is not going to exist? How many for 2? Can make 0 comma 2, you can make 1 comma 1. If you look at this pattern, right, if you look at when this value was, let's say this value x was 1, x was 2, x was 3, so on and so forth, you will notice that a formula exists. Someone told this in the chat as well. It's nothing but AI divided by 2 plus 1, and this is floor division. Basically, when AI was 3, 3 divided by 2 is 1, plus 1 is 2. So you can see we can make 2 pairs. Similarly, 2 divided by 2 plus 1 is nothing but 1 plus 1, 2. And as you can see, we can make 2 pairs, right? Is this much clear, guys? Tell me. I wanted to count this, okay? Number of pairs such that x plus y is there. How do I do this? I just iterate over elements and it's summation of ai divided by 2 plus 1. This is what my number of pairs such that x plus y exists. Okay. Now, what is the other thing that you have to calculate? You have to calculate, it is 1, 2, 3. Okay. What is the number of pairs such that y minus x results in that difference? Now, as you can see, it is very, very, very simple. For this value, it is going to be 0 comma 1. Then it is going to be 1 comma 2. Then it is going to be 2 comma 3. For this, it is going to be 0 comma 2. Then it is going to be 1 comma 3. Here it is going to be 0 comma 3. Again, all of these are going to be disjoint. Okay, right? So How do you count this? Anybody in the chat? Let's say I have 1. Okay. I can make y is equal to 1, 2, and 3. Now, if AI was 2, I can make it 2 and I can make it 3. And its corresponding values are also 0 and 1. So, since I can take all values from this to see how many values are there from AI to C, how many values are there? The number of values are just C minus AI plus 1. Isn't it the number of pairs that we can make? Basically, I could take Y as 1, I can take it as 2, I can take it as 3. Similarly, for 3, I could have taken it as 3. Here, I could have taken it as 2 and 3. The formula is just C minus AI plus 1 because I can take all elements as Y as AI, comma 0, 1, comma AI plus 1 till the point this is C. How many values are these? This is C minus AI plus 1. The number of elements in a range. Is this much clear? Put a yes in the chat if this is clear, right? Okay. So what did we discuss till now? We discussed that we wanted to count x plus y. This is just summation of AI divided by 2 plus 1. We wanted to compute y minus x. This is just summation of c minus AI plus 1. Okay. Now what do I want to calculate? I want to calculate how many pairs are there such that they satisfy x plus y and they also satisfy y minus x. Okay. Now for this, I'm going to use a counting principle and I'm going to show you how. This is basically the most trickiest part in the problem. Okay. Now, the thing is, the array is given in sorted order. So we know 1, 2, and 3. For every element as I'm going ahead, okay, what am I going to count? How many x comma y are there such that x plus y is AI, okay? X plus y is AI and y minus x exists in this prefix. This is what I am going to count, okay? And keep in mind that this is in sorted order and all of these elements are unique. So this is sorted and all elements are unique. Is this much clear, guys? What am I going to do when I'm on an index I? I'm going to calculate how many pairs are there such that x plus y is equal to AI and how many like and as well as y minus x exists in prefix. Okay. Is this much clear, guys? Tell me. Okay. Now, if this much is clear, let's see for 3. Okay. 1, 2, 3. Let's see the values x comma y such that x plus y is equal to 3. Weber says repeat this part. Okay. I'm going to use a counting principle to count this particular thing. Okay. I'll just write it down. I will iterate from 0 to n minus 1. Okay, my index. On each index, what will I count? I will count the number of pairs x comma y such that x plus y is equal to AI and y minus x exists in the array. Okay. Now, the thing to notice is that this is going to be disjoint from every other index because x plus y is equal to ai is unique for every I. Unique for every I. Basically, since all the elements are unique in the array, the number of pairs that I get for every index such that x plus y is equal to ai and y minus x exists in the array, it is going to be unique. Basically, it won't collide with any other index. So if I just take the summation of these values, I will get my A union B as well. Okay. Now, since you get this, right, let's take my array 1, 2, 3. What are the pairs x comma y that I can make? I can make 0, 3. I can make 1, 2, right? And I can make, yeah, these are the two things that I can make, right? Now, what is y minus x here? Y minus x is 3. What is y minus x here? Y minus x is 1. Okay. Now, let's take, like this is something that we noticed. Let's take for 2. We can take 0, 2. We can take 1, 1. What is y minus x? 2. What is y minus x? 0. If you notice, okay, if you notice this pattern, these values will take all, like if this is odd, it will take all odd numbers from 1 to ai, and this will take, if this is even, it will take all even numbers from 0 to ai. Do you guys agree? Tell me guys, do you guys agree upon this? Because 0 to 0 plus 1, 2 minus 1, 0 plus 2, 2 minus 2. If you go so on like this, these are always going to be even numbers and it keep reduces by 2. This is 2, this is 0, this won't exist. Okay. Now, since it takes all odd numbers from 3, 1, so on and so forth, what do I need to know? If I am at AI, I just need to know how many elements aj such that aj smaller than equal to ai and aj modulo 2 is equal to ai modulo 2. This is all that we need to know, because what did we want to calculate? X plus y is equal to ai and y minus x exists in array. Okay. What did we decompose it into? That we want to check how many elements are there in the array aj such that aj is smaller than equal to ai and the parity is the same. Okay. Now, if you just notice this, since the array is sorted, right? Since the array is sorted, right? 1, 2, 3, 4, 5, 6. If you are at an element 5, you just need to count the number of odd elements that are there till this index. If you are at an even element, you just need to keep the count of number of even elements till this index. So if this is odd, you will just add the number of odd elements to your answer. And if it is even, you will add the number of even elements into the answer. Is this much clear, guys? Just to recap, we found out that the answer will be total minus something. Okay. Right. Now, what is this something? This is just a plus B minus A union B, right? Even odd wala proof. Okay, Vishesh says he wants a proof. We'll get to that proof. Okay. And what is A? A is the number of pairs such that X plus Y exists in the array. B is Y minus X exists in the array. Okay. Now, Vishesh asks, why is it always like, let's say we are at 3, or let's say we are at 5, okay, and C is 5. I think you'll be able to see this better here. 0, 5, 1, 4, 2, 3, right? No, not so much, but okay, fine. 5 minus 0 is 5, 4 minus 1 is 3, 3 minus 2 is 1. Okay. If you see, right, this 0, 5 gives 5. Now, to the bigger number, you reduced it by 1. You made it 4. Okay. So the subtraction, if it was 4, 0 only, it would have been 4. But then you increased this 0 by 1 also. So this difference reduced by 3. And after that, you made this 2 and you made this 3. So the difference reduced by again this difference again reduced by 2. It became 1. And how many elements are there? There are AI divided by 2 plus 1 such elements, right? And how many, like if this is AI, how many odd numbers are there from 1 to AI? Again, there are AI divided by 2 plus 1 elements. Basically, if you look at 1, 2, 3, 4, 5, right? How many odd elements there are there? There are 5 divided by 2 plus 1 odd elements, which is basically 3 odd elements. And if you look at this, it is 0, 5, 1, 4, 2, 3. So 5, 3, 1. So this is always going to be odd, okay? And it is always going to take all the odd numbers from 1, 3, 5. And similarly, you can prove it for 4. So since this is clear, let's move on to the code. The code is actually fairly just very simple. You don't need to binary search or combinatorics over there. You just have sum as a variable and you have odd and even numbers as a variable. The total number is oh wow, my battery is low. My phone will die. My laptop will die. Okay. So the sum is C plus 1 into C plus 2 divided by 2, the number of pairs. Now we just subtract using inclusion exclusion. So the number of pairs that add up to a value, the number of pairs that subtract to that value. Now I just increment. If that number is odd, then I do odd plus plus. If that number is even, I do even plus plus. I'm just using fancy stuff to do this. You can just write a if statement. Okay. Now, if my element is odd, I add back the value which I took twice, right? So sum plus equal to odd, otherwise sum plus equal to even. You can do this separately as well. I'm doing everything in one for loop, but you can calculate this separately in a for loop. You can calculate this separately in a for loop. You can calculate this separately in a for loop. And then you can apply the formula. What formula you can apply? Total minus A plus B minus A intersection B. Is this much clear, guys? Great. So we were able to successfully solve A, B, C, D. I hope you were able to understand the problems and the solution. D was pretty simple. It was math, right? And math is good. And C was a bit of implementation. I hope you liked the post-contest discussion, right? You can feel free to fill the feedback form and let me know what I can improve upon. Thanks a lot for watching. Meet you next time. Just stop recording.